Hey everyone, so today we are going over our last naming lesson, which is when we are naming acids. So we know how to name ionic compounds, which are metal nonmetals. We know how to name covalent compounds, which are nonmetal nonmetals. And now we got to know how to name acids. First thing we got to do is we got to be able to identify if a compound is an acid or not. The way we identify that is if it starts with an H, okay? All acids start with an H because they like to give up that proton, which is H+. As you notice, these are all acids. They all start with H, HCl, HBr, H2S, H2SO4, HNO3, H3PO4. You might be wondering, are there exceptions to this? Because you are probably thinking of a compound right now that starts with an H. That is not an acid. Yes, there are two exceptions to this of compounds that start with H that are not acids. So exceptions, you might be able to think of one. Water, okay? Water is not an acid. It is neutral. It has a pH of 7. So that is one exception. Another exception is H2O2, which you better know as hydrogen peroxide. It is not an acid, but it is very corrosive. It can still eat your skin. It's almost as corrosive as our strongest acid. Hydrogen peroxide is very, very dangerous. You just get a very diluted form that is only about 3% hydrogen peroxide. But hydrogen peroxide in its full concentration is really dangerous and will eat your skin. So, how do we name things with acids? And the big thing is when you identify it as an acid, the first thing you got to say is, does it have an oxygen or does it have no oxygen? So, if it has no oxygen, we name it as hydroblankic acid. Okay? And I'll explain that here in just a second. HCl. I'm looking at HCl. I know it's an acid because it starts with an H. And then I say, does that have an oxygen? No, it doesn't have an oxygen, right? It's just HCl. So what I'm going to do is I'm going to say, okay, it is hydro, and then what goes in this blank? Chlorine. I'm just going to keep the prefix of that and put it up here. So it's going to be hydrochloric acid. So what helps me decide the name of this acid is whatever ion is paired with that H. Okay, so the ion paired with H is Cl, that's chlorine, so it's going to be hydrochloric acid. Right? HBr. No oxygen, so it's going to be hydro. But bromine, we're going to keep the prefix, so it's just going to be hydrobromic acid. H2S. H2S. What is that going to be? What do you think? No oxygen. It's just hydrogen bonded to a sulfur. So it's going to be hydro, and this is going to be sulfuric acid. You could put sulfic acid, okay, but sulfuric acid sounds better. So that's just hydrosulfuric acid. Okay. So no oxygen, hydroblankic acid. HCl is your stomach acid. Kind of strong, not extremely strong. Usually the more oxygens acid has, the stronger it is. So let's go to those guys, are really, really strong acids. Has oxygen. So if it has oxygen, there's no hydro, okay? But we are just focusing on the polyatomic ion that is attached to the hydrogen. So we're going to be focusing on SO4, NO3, and PO3 for these examples. If the polyatomic ion changed to 8 or ends in 8, so such as sulfate, nitrate, phosphate, we're going to change that ending to ic and just put acid on the end. So sulfate becomes sulfuric acid, nitrate becomes nitric acid, phosphate becomes phosphoric acid. Okay, chlorate, chloric acid, and so on and so forth. If the polyatomic ion ends in ite, we will change it to us acid. So nitrite will become nitrous acid, phosphite will become phosphorus acid, and sulfite will become sulfurous acid. Okay? Again, no hydro, but we're changing ate to ic, ite to us. Feel free to put that on your periodic table. Okay? So let's look at these acids. I know they're acids because they start with a H. And I look at the polyatomic ion, and that is sulfate. Okay, sulfate. If I look at my rules, remember, if it ends in ate, we change it to ic. So sulfate is going to become sulfic or sulfuric acid. So this is going to be sulfuric acid. Sulfuric acid is typically what's in your car batteries. Okay, if you are smart enough or have the resources to sulfuric acid, you could actually replace the sulfuric acid in your battery, scrub those metal anodes and cathodes, and you could have a nice fresh battery. Probably won't be as nice as just buying a brand new one, but you could recharge your own battery if you have access to sulfuric acid. HNO3. Alright, that's got a polyatomic ion in it, it's got an oxygen. So I look at the polyatomic ion, NO3 is nitrate, which you could look at right here. Nitrate. So if it ends in ate, it's going to be ic. So that is going to be nitrate, nitric acid, which is actually our strongest acid. Okay? Usually the more oxygens it has, the stronger it is, but nitric acid has some really strong dipole moments in there, which makes it really able to eat your skin off. These guys, when they hit your skin, they won't eat it automatically. It might just irritate a little bit, but if these guys touch your skin, it's going to bubble. So beware of these acids with oxygens in them. And this last one here, it's got an oxygen in there, so I'm going to look at that polyatomic ion attached to that H, which is PO3, which is phosphite. Remember, if it ends in ite, it goes to us. So phosphite, you could say phosphus, but phosphorus sounds better. So this is going to be phosphorus. Phosphorous acid. Okay? So again, no oxygen, hydrochloric, bromic, hydrobromic, hydrosulfuric, hydroiodic, hydrofluoric. Okay? These are all the no oxygens. If it has oxygen, ate to ic, ite to us. You'll hear me say that a lot. So let's go ahead and name a few of these. Alright? So, say I have HF. I look at this guy, ionic, covalent, or an acid. Well, it starts with a H, so I know it's going to be an acid. So now I go to my rules. Does this have an oxygen or not? No, it does not have an oxygen. So I'm just going to start off with hydro. There's no oxygen, it's hydro, and then it becomes blank-ic acid, which is based off of my ion attached to the H. So it's not just fluoric acid, it is hydrofluoric acid. Not a strong acid by any means, but it is really small, right? Fluorine small, hydrogen small, so it could get under your skin. It could actually get through your pores and then eat your skin from underneath. So, not a strong acid, but a highly dangerous acid. Let's go ahead. Let me throw in another one here. I look at this guy. First, ionic, covalent, or an acid. It's an acid, right? It starts with an H. So, I look at it, does it have an oxygen? Yes, it does have an oxygen, so there's no hydro on this one, but I'm just going to look at this polyatomic ion. CO3, I go to my polyatomic ion sheet, I see that CO3 is carbonate. Ate to ic, ite to us, so carbonate is going to be carbonic acid. Gotta add acid at the end. Carbonic acid. One more before we go to reverse from name to formula. Let's go with HClO. Covalent, ionic, or an acid. It's an acid. Okay, it starts with an H. So, does it have oxygen? Yeah. So, I gotta look at that polyatomic ion. ClO is hypochlorite. Hypochlorite. So, remember, 8 to ic, ite to us, it ends in ite. So, that's gonna be hypochlorous, right? Ite to us, it was hypochlorite. It becomes hypochlorous. And at the end, you gotta add the acid. Okay, let's do a couple examples where we go from formula to name, or name to formula. Alright, so now we're going backwards. We're going from name to formula. So first thing you gotta do is if you ever see acid in the name, you know you're gonna have something that starts with H. Okay, so acid is the dead giveaway to know that you are doing a formula that starts with H. So I look at the first one, and I see Hydroiodic Acid. When I look at this, I see hydro, and I say, okay, there is not going to be an oxygen in this formula. Hydro tells me there is no oxygen, so it's just going to be a singular element. Iodic, what does iodic sound like? It comes from iodine. I look at iodine, and it has a -1 charge. Well, now I just got to add enough H's to make it neutral. Remember that H has a +1 charge. So to cancel out that -1 charge, I just have to add 1 hydrogen. So that is hydroiodic acid. I see that it says hydro. It's got to be just one element without oxygen. I see iodic. I'm thinking that comes from iodine. And then I balance out the charge with my hydrogens. I go ahead and I look at the next one. It is perchloric acid. There's no hydro here, so it must come from my polyatomic ion sheet. Perchloric. Remember, 8 to ic, ite to us. So if it ends in ic, it must have came from 8. So if it's perchloric, it must have came from perchlorate, which is ClO4, and it's got a -1 charge. Now what I gotta do is just balance out that -1 charge with hydrogens. It only needs 1 hydrogen, so those positive and negative charge will cancel out, and it's just HClO4. Next one, sulfurous acid. There's no hydro, so it must come from a polyatomic ion. 8 to ic, ite to us. This ends in us, so it must have came from ite, right? Ite to us, so not sulfurous, but sulfite. I look on here, I look for sulfite. It is SO3 2 negative. SO3 2 negative or -2. Well then, how many hydrogens am I going to have to add to make this neutral? Remember, hydrogen has a +1 charge, so this must be H2SO3. Sulfurous acid gets rid of that 2- charge. Last one, hydronitric acid. It has a hydro in it, so it's probably just going to be an element on the periodic table. No polyatomic ion, it's got hydro. And then I see that nitric. I'm thinking that's probably just going to be nitrogen. Okay? Nitrogen has a 3- charge. So how many hydrogens am I going to have to add? 3. H3, hydronitric acid. So that's how we go from name to formula. Make sure you're getting practice with that. Remember to make sure to see if it's ionic, covalent, or an acid first. Try out that practice, check your understanding, and have a great day.